All right, guys, let's take a look at our second example as it relates to cumulative frequency curve. Okay, so here's the question. Now it says the table below shows the scores obtained by 80 students on a multiple choice exam, and there we can see the frequency table. Now, of course, number of students here also means frequency. Okay, you should know that by now. All right, so that also means frequency. So it says we have 1, 2, 3, 4 classes of scores. So they did a multiple choice exam, and these are the scores that they got out of the set questions. All right. So 7 students scored from 20 to 29, 21 students scored from 30 to 39 marks, 36 students scored from 40 to 49 marks, and 16 students scored from 50 to 59. All right, so we need to complete the cumulative frequency column first of all. So this is part A of the question that says copy and complete the table. So cumulative frequency, always start with the value that is here. Then 7 and 21 is 28. 28 and 36, that is 64. And 64 and 16, that would be 80. So you can see here that the 80 matches the 80 students in the question. So in the statement at the beginning of the question, so 80 students here represents a total frequency or total number of students. So we have essentially done part A. Now part B says, using a scale of 2 centimeters to represent a score of 5 on the x-axis. Note, begin at 15 instead of 0 on the x-axis, and a scale of 1 centimeter to represent 5 students on the y-axis. Draw a cumulative frequency curve to represent the data. Now, before we can do that, we have to come back to the table here. Let me put that on that side and generate what we call our plotting points, of course. So let us get to that. All right, so we want to be able to generate our plotting points. So, of course, this class here, 20 to 29, the class boundaries for that class would actually be, let me just come here, that would be 19.5 to 29.5, and of course that is supposed to match up with 7. We haven't established the upper class boundaries yet. I'm just writing the boundaries for each class. So for 30 to 39, that would be 29.5 to 39.5, and that should match up with 28. Of course, it matches up with the cumulative frequency. All right, 39.5 to 49.5 should match up with 64, and 49.5 to 59.5 should match up with 80. All right. So what we have to do now is establish now, using the upper class boundary, the specific point. So this is what is actually going to map up with these guys here. So I'm just going to set this out here clearly so we know what we're plotting what against. So really and truly, we're going to be plotting. Let me just draw this line here. What we're going to be plotting is, first of all, 29.5 is going to map up directly with 7. So remember that this is a class boundary, and this is a cumulative frequency. All right, cumulative frequency, class boundary. Or we can do it the other way around, it doesn't really matter. I know in the previous question we put this first, but we just map it up against the corresponding amount. So this is cumulative class boundary, this is cumulative frequency. All right. So as a matter of fact, let's keep it consistent with what we were doing before, so that kind of becomes your practice. So let's just do it this way, since you're already accustomed to that. So we're going to map 29.5. We're going to map that with 7. So we're using the upper class boundaries here. We're mapping 39.5 with 28. We're mapping 49.5 with 64, and we're mapping 59.5 with 80. Now, of course, one is missing at the top. You should remember that because without that, the curve would not be touching the horizontal axis. So this guy here, 19.5, actually maps with 0. So we have to remember that. All right. So 19.5 maps with 0. All right. So we have to remember that. Okay. So again, cumulative frequencies here and class boundaries here. So this is what we're going to be focused on in terms of plotting. So remember, cumulative frequency, class boundary. Cumulative frequency is always a y-axis and class boundary is always the x-axis. Now, it doesn't matter whether you want to write it this way or you want to go ahead and do the reverse, meaning 0, meaning this is the cumulative frequency, and the class boundary 0 maps with 19.5, 7 maps with 29.5, 28 maps with 39.5, 64 maps with 49.5, and 80 maps with 59.5. It doesn't matter how you want to lay it out, whether you want to put the class boundaries first or the cumulative frequency first, or in this instance the cumulative frequency first and the class boundary first. Is really left up to you, whichever way comfortable. Just know that you plot correctly based on the axes and what the axes represent. All right, so we have the plotting points. I think we're accustomed to doing it this way from example 1, so we can stick with this. So 0 maps on to 19.5, 7 maps on to 29.5, 28 maps on to 39.5, 64 maps on to 49.5, and 80 maps on to 59.5. So we can actually just stick with that then if you're more comfortable with that. All right, so we can go ahead quickly and do the cumulative frequency curve on the graph sheet. So we're going to come here and get this done as quickly as possible. Now, the first thing we need to do is number based on the scale. So we're going to come back to the sheet that speaks about how we should number. So it says here, using a scale of 2 centimeters to represent a score of 5 on the x-axis. And it says also begin at 15 instead of 0 on the x-axis. So the x-axis here, we're actually going to begin at 15. So 15, and for every 2 centimeters, remember this is 1. So every 2 centimeters we're going up by a score of 5. So this is 15, 20, and you can see clearly that it would trap the first reading of 19.5 because we could easily find 19.5 here. Now remember, depending on the scale, we're going to count differently. So if this is 15, then this would be 16, 17, 18, 19, and then 20. So in between now would be the 0.5. So 15, 15.5, 16, 16.5, 17, 17.5, 18, 18.5, 19, 19.5, and 20. So locating the 0.5 now is far easier when you have a scale like this. All right? But anyway, let's just continue. 25, 30, 35, 40, 45, 50, 55, 60. All right, good. So that deals with the x-axis. Now it says here, and a scale of 1 centimeter to represent 5 students on the y-axis, draw a cumulative frequency curve. So on the, we should use a scale of 1 centimeter to represent 5 students on the y-axis. And we know the y-axis is also referred to as the cumulative frequency, which represents number of students. So for every 1 centimeter, we're going up by 5 students. So this is 1 centimeter here. So that's 5, 10, 15, 20. So this would be 0 here. So 0 begins the y-axis, 15 begins the x-axis. So this point here is 15 going that way, that point here, 0 going up. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And again, why am I stopping at 80? Because the total number of students is 80 and I don't want to go past that to create any problems for myself. So there it is, the scale that I'm going to be using to determine the cumulative frequency curve. So we're just going to follow this, right? So remember the first one is cumulative frequency and then the class boundaries. You can't miss the class boundaries because they always have the 0.5 and that is always on this axis here. And the cumulative frequency is here. So the first one is 0 to 19.5. So 0 to 19.5. So this would be 19 here and then 19.5 is right here. Can't miss that one. The 0.5s are easier with this scale. All right. Next one is 7 to 29.5. You can see that here, 7 to 29.5. So we find 7. So 5, 6, 7. So this actually here is 7. And we're going to link that up with 29.5. And 29.5 would be here, right? Because this would be 29.5. And we map that up with 7. And 7 would be here. All right. So 7, 8, 9, 10. So 7 would be right there. Very, very straightforward. I think we have a couple more to do. 28 maps up with 39.5. So 28 is 25, 26, 27, 28. So here is 28. And that maps up with 39.5. So this would be 39. 39.5 is here. And that maps up with, this is 20. This is 25, 26, 27, 28. So this would be 28 here. So we have 3 points so far. One, just brightening them for emphasis, but you don't need to make them this bright. So 1, 2, 3. So I have this, this, and this done already. So I need to get these two done and then I'm good. So 64 maps up with 49.5. 64, 60, 64 would be here. So 64 maps up with 49.5. So 49.5 would be this line going up here. All right, so I have to be very careful sometimes. Let's make a check. This is 40, 45, 50, 55, 60, 61, 62, 63, 64. Right there. All right, so you take your time and make sure you don't make any mistakes. And you can clearly see that it's making a nice little curve, that little characteristic S shape. And then the last one would be 80 maps up with 59.5. Now this line here is the 80 line, so I'm just going to come across here in case you're having difficulty mapping it back up. So I'm just going to make it a little easier since I'm closer to this side. So 59.5 would be this line here, second to last line, and that maps up nicely with that. So you can clearly see the cumulative frequency curve taking shape. So just try to get a smooth curve. Try to avoid the excessive leaning in and going up. I know it's difficult when you're doing freehand, and some person's hands are not as steady as others. Make sure it goes through the pointer as well. So take your time. I'm doing it a little haphazardly because I'm trying not to get too much in front of the camera. All right, so there we go. All right, not bad. So we should try as best as possible to get the curve going through the point. So anyway, we have the cumulative frequency curve, and that's a good thing. All right, so part B is out of the way. So I'm finished with that. So part C now says using the graph determine, so let's look at this quickly. Using the graph determine the median score. Now quickly, 80 is the top value, so we divide that by 2 and get 40. So we're going to come from 40 to get the median score. So we're coming across from here. Of course, use a straight edge, but this is nicely on a line, so it makes it a little easier for us. And it touches exactly there. And we're just going to come down with that. And try to keep it on the line. All right. So it goes down to this value. All right. And this would be 40, 41, 42, 43, 43.5. So this value here is 43.5. So that's the median score. So the median score here Just making a note of that. The median score here would be 43.5. It could be off a little bit, but not too much. I'd say by maybe 0.5. But so if you get 43 or 42.5, anywhere around that region, not so bad. All right, or maybe 44, but they can't. So I'd say 44, 43, or 42.5. Anything outside of that, they're going to mark it on severely. All right, and the last one says the probability, which should be in fraction form, that a student chosen at random scored no more than 45. Now for the probability, obviously it's 80 students, so 80 comes there, and the top is what we need to find. But it says no more than 45, so it could be 45 or less. So the probability that a student chosen at random scored no more than 45. So he could have scored, he or she could have scored 45 or less. So we need to find 45, which is here. 45 is right here. So we need to carry this up using a straight edge. But there's a line there already, but I'm just using the point here for emphasis. There's a line there already. So I'm carrying this up. Very straightforward to the curve. And then where it touches the curve, I'm just going to come across like this. Alright. And it matches up with 45, coincidentally. 45 here. So it says, using the graph, determine the probability of that a student chosen at random scored no more than 45. So what it would want is students who scored 45 or less. So it would be the body here, so 0 to 45. So it would actually be 45 students. The ones up here would score 45 marks or more. So that would be the difference between 80 and 45, which is 35. But they said no more than 45, so it would mean the 45 students down here would have scored anywhere from 45 down to 0, essentially. So 45 students scored no more than 45 marks, coincidentally. So that means we have 45 here. Now that, I think that can be broken down, and I should always break it down when it can be broken down. So let's see, 5 can go into 45 9 times, and 5 can go into 80 18 times. So that should be your probability. All right. Sorry, 16. All right, 5 16 is 30. 5 6 3 and 5 1 and 3, that's 80. All right, so the probability should be 9 over 16, because this can be broken down. 5 can go into 45 9 times, and 5 can go into 80 16 times. So the probability would be 9 over 16. All right, so gentlemen, again, here's the cumulative frequency curve. All right, so we did it. So it's a little bit difficult doing these technical things and watching the camera at the same time. So it's a little bit tricky to make sure I don't go over the time, because once it passes 20 minutes, then it becomes difficult to edit from the phone because there's no storage. But here it is. So I hope again you found this video insightful, and I'll see you guys on the next video.